Hello, everyone. My name is David Grimmer, and I'm a director of marketing here at Radview. We are very excited having you with us today and hope to get the most out of the upcoming session. I'm kindly reminding everyone that this session is being recorded and will be shared within a couple of days through YouTube and email, of course. And before we get into business, I'm pointing out that an open Q&A session will take place at the end of the webinar. Although feel free to drop your questions within the chat and we will do our best to address them all during the session and of course at the end of it. So for any of you guys which are not familiar with us, Radview is an enterprise-grade testing solution provider, allowing R&D organizations to accelerate their testing cycles within load and automation testing. And with me today is Firas Matar, Chief Product Officer here at Radview. Firas is the co-founder and former CEO of Shield 34, an AI-based test automation platform for web applications, which was recently acquired by Radview. Prior to that, Firas also led HP product team and is being considered as one of the leading experts within the software testing industry. So without further ado, I will now hand over the mic to Firas.
Thank you, David. Hello, everybody, and thank you for taking the time and joining us in this webinar. Hopefully at the end of the webinar, I'm gonna leave us with a few new things that we've managed to convey. Without any further ado, let's start right away. So the agenda for today. So we're gonna start with talking a little bit about quality versus R&D velocity, and eventually how everything is dependent on quality and test automation. Then we're going to move to the major part of our webinar, which is around the pitfalls and best practices. And we're going to dive deep into lots of material here in regards of pitfalls, and we've selected some pitfalls which we think are very popular. We're working with lots and lots of companies, and I've seen lots of tens, if not hundreds, of test automation projects over the year, and those are the things that we've seen a lot. And other than that, we're going to discuss the pitfalls that maybe not being discussed enough in the community out there. So hopefully you will learn new topics that you didn't maybe think about before. And lastly, as David mentioned, we're going to go into a Q&A session. So let's start with quality versus velocity. So as you know, as I'm assuming you as well are, we're going with agile, DevOps, all this. I'm not going to call them buzzwords, but there are lots of other buzzwords out there that you hear on a daily basis. But eventually, all those R&D methodologies are going for quick time to market, efficiency, and whatnot. But what is important for us to emphasize here, that all those methodologies, Agile, DevOps, and the rest are powered by test automation. Without test automation, any of those methodologies could exist. And this is a major take, and this is something very important for people to understand, is eventually, if you're not investing enough in your test automation, you want to be able to do DevOps, CI/CD, Agile, or whatever you call it properly. Because eventually, those are the major pillars of your organization. And eventually, as we've said, CI/CD relies heavily on test automation. But what happens when you get flaky tests? Like any company dealing with test automation today, you would get lots of flaky tests, So Flaky test, for those of you who don't know, is basically tests, automated tests which fail, although the functionality they are testing is not broken. So it's not a real failure that you're looking for, it's more a false positive. And according to several researches, around 28% of the tests in companies are flaky on average. So it's, let's say, a third of your tests are flaky. So that's a huge number. And eventually, when you get failed tests as part of your test automation, all this CI/CD, continuous integration, continuous deployment, it just becomes discontinuous. Just like that, your pipeline is broken because all the automatic stuff, all the automation stuff stops there, and you kick in with the manual stuff. So you're investigating the failure. So manually and not using any automation stuff anymore. When your pipeline is broken, when you have failed tests, so the build is red, and when that happens, R&D is stuck, and it's the whole R&D. They can't commit any new code eventually because there's some, let's say, not correct code eventually, which got into your CI. And then when the R&D sits and investigates what was the failure, it's basically they're invested more in maintenance rather than new developments. So the R&D velocity goes down. And we've discussed earlier an almost 30%, third of your tests are flaky. So get this scenario, which happens in every company. Your top developer, test engineer, DevOps engineers eventually spend hours, if not days, on fixing or investigating and trying to fix failure, and only to find out at the end that it was a flaky test. So we like to use this picture very much because it emphasizes exactly what happens on lots and lots of companies that we have worked with. Eventually, you think that you're riding a horse or maybe a Ferrari or something like that, but because you're not investing enough in your test automation, eventually it's anything but quick. So that's it regarding the problem that we're trying to tackle, and trying to, if you're not fully convinced that you should invest in your tests in regards of flakiness. So we hope that you are totally convinced now. And now we'll move on to the pitfalls themselves and best practices that we recommend you to implement. At the end, as we've mentioned earlier, at the end of the webinar, when we finish with all the pitfalls, you will leave this webinar with well-defined, tasks or stuff that you can implement on your own in your testing frameworks or in your R&D organizations, starting right away, right after the webinar or tomorrow morning. And that's eventually our goal. So let's start. Let's start with the first pitfall. That maybe is going to be the only one, which is talking about a pitfall which is discussed much in the community, but still we see all the time people still do that, and it's causing them lots and lots of issues. So we found it important to emphasize here: do not use implicit waits. So for those of you who do not know what implicit wait is, So implicit wait, just, it's one line of code that you can add to your testing framework, and eventually that tells Selenium to wait up till the timeout that you specify there before executing or before failing any command. So that's one line of code which eventually would add some kind of waiting to all the Selenium commands. That's a very bad practice because eventually you want to control your waiting. You want to specify and define to Selenium when to wait and when not to wait. This could if you have some kind of a bug in the application, it could also make it disappear. And so eventually that's a very bad practice and you shouldn't use that. So you can search your testing framework. If you have this line of code, make sure to comment that out or even delete it right away, and instead use explicit waits, which we're going to cover in a second. Also, it's a given as well. Don't use thread sleep. Here, for example, we have thread sleep for 5 seconds. Let's say that some kind of the network was a bit slower that day, and it took 5 seconds and a half. So that would break the test. So that's totally breakable. And instead use explicit waits. And I'm sure that most of you are aware of this terminology. So explicit waits were they weren't part of Selenium right from the early days. So the Selenium team have added this capability a few years ago because it's very needed, and that's what we recommend you to do, is specify when you want to use a wait before a specific command, and do not use the general one, which will cause you problems and will cause some serious flakiness to your tests. So that's regarding waiting. So use explicit waits and not implicit waits. Let's move on to number 2. So here we're talking about the properties that you use eventually to locate elements. Okay, so what we recommend, we do it ourselves, and we recommended that to lots and lots of our customers, and it just works. Eventually, when you're trying to locate an element with Selenium, you're eventually, using the ID or the class name, or as you can see here in the screenshot. The issue is that those attributes or those properties gets updated all the time by your developers. And when they are updated and changed, they would break the test automation, because that's what you use to locate elements, and tests would break then, although the functionality was not broken. Let's say they have only changed this class name, but everything, the buttons still clicking the same as they used to. So the functionality wasn't changed, but that would break a test, and that would be another false positive or flaky test. Depends on how you want to define it. So what we recommend to do is, or maybe another sentence before that, when a developer wants to change something in the HTML, they don't know what is being used by the tests and what is not being used by the tests. So they don't have this visibility to be able to know, okay, this is being used by our test automation, so I'm not gonna touch it, I'm not gonna change it, or I'm gonna talk maybe to the test engineer before changing anything in this regards. So what we recommend to do is to do have this visibility for the developers, what is being used by the test automation, and doing so by adding properties to the HTML with a prefix, for example, auto for automation. So for example, auto click button. And here you can see that's an example from our website, from Radview's website. And here you can see we've added to the class name of this A tag, auto get a demo button middle. So it's in the middle of the page. We have, several copies of this button. So then when our developers, have some requirement to update this HTML, when they see auto minus something, so they know that this is being used by the test automation, and if they want to change any component, something in the page there, they would make sure that this either gets back in or being updated to the new button that they are replacing this button with, and even if it's not the same button and the page is being redesigned a bit, stuff like that, they would know that they should talk to the test engineer and have this conversation or communication about, okay, this is the change, what should I do with the locators, and that would just lower your test failures on just locators that have been changed drastically. That I can't emphasize that enough. Where we were before having this and where we are today, when we do have those properties, and eventually, if this is not available on your side, we recommend to prioritize your locators by first go for ID, then class name, then name, tag name, link test, or any of those, or then only then go for XPath and CSS. This is being prioritized first by uniqueness and then by performance. So when you're searching, when you're doing a find element using an ID locator, it's much faster than an XPath or CSS. Okay, so let's now move on to the third pitfall. So it's regarding hard-coded strings. So I'm sure that in all your testing frameworks, you see lots of such lines of code. When you have some kind of an assert, and eventually you're getting something from the UI, and you're comparing it, have some some logic there with a hard-coded string. This is a hard-coded string. Radview test automation is a hard-coded string. So here, we're expecting to have Radview test automation somewhere in the UI. Okay, it doesn't matter what eventually we're doing, but we expect this string to be in the UI when the test reaches that point. The issue with this line of code is that if Radview test automation, have been changed a bit, there was a requirement from the product team or the marketing team to add another word after this test automation, or to make this a capital letter or a small letter or something like that, and then the developers go and implement that requirement that you got from the product team, that would break the test, because the string that we're getting here from when we're interacting with Selenium is not Radview test automation anymore. So what we recommend to do is today in almost all the UI frameworks, there are some kind of strings management tools like I18N or all the localization and globalization tools. So eventually we recommend that you would also get instead of the hard-coded string here, try and read it from that system. So for example, this is an example of an I18N file. So this is a file that is being managed and used by developers. And eventually I could have got Radview test automation right from here. It's a JSON file, and I can ask the developer or try to figure out myself where this string sits, and eventually I could just read that from the system. And anytime Radview test automation is being updated here, then my test would be updated with that automatically without having any failures. And eventually those mainly are flaky tests. So try and get access to those string management systems. If you would have a quick word with one of your UI developers, they would instantly understand what you're talking about, and they can direct you to where exactly they are storing this. And if you can, and eventually you will be able to access it, and instead of having hard-coded strings in your test, just read it out from there. So that would be number 3. Let's move on now to pitfall number 4. And the best practice here that we're recommending is, once you implement all the best practice that we have here in our presentation, our webinar, and all the best practices that you would find on the web, eventually you would lower your false positive to 1% or even less than that, but still you would have tests that would still be flaky and would still be failing on stuff that they shouldn't be failing in. So what we recommend to do in this case is to get all your failed tests at the end of the test automation run, at the end or maybe after the tests have failed, and rerun those again. So depends on the logic in your test. So you can run the test right after it has failed, or wait to the end and then rerun all your failed tests, and only then report the results of the test automation run. When you if there was a failed test which you reran and it was successful, then you should report it as a successful run. And depends on the framework that you're using. So this is an example of from TestNG. So TestNG already has a built-in capability of getting all the failed tests, and eventually this retry analyzer look it up, and this eventually what helps you in getting all those failed tests. And you can just copy the code from here, and eventually this is where you would specify all the logic, what you want to do eventually with all those failed tests. So this would lower eventually your, and maybe I would add a disclaimer here that we recommend on implementing such a functionality only when you have implemented all the other stuff, because if you're having 30 or 40% of your tests are flaky, then this wouldn't help you much. This would be very helpful if you've already gone to a point where you're in a good stage in regard to flaky tests, and that would give you that next step to reach maybe a 0% flakiness. So that would be our number 4. Moving on to the next one. So this is maybe not getting emphasized enough in the community. Eventually, you don't want to run your test on a machine that looks like this. So that's a very bad practice. This high CPU RAM storage on a crowded network, or whatever, all the stuff eventually would cause lots and lots of flakiness, and eventually you want to keep utilizing your machine resources for the best results. We intentionally are not giving here, any magic numbers, because magic numbers do not exist. So every application consumes machine resources differently. So you need to check that out for your specific application that you're testing. And if you are running tests in parallel, and if you're running, let's say, several browsers or several tests in parallel on the same machine, using Selenium grid or stuff like that. So you need to make sure that the number of threads you're using in parallel on the machine won't get your machine overloaded with any of its resources. So make sure to monitor that at least at the beginning, to understand what are the number that makes sense for your application, and then move on from there. Number 6. So here, we're number 6 and number 7. We would recommend, especially for those two, using some external tools which would help you, which already have implemented lots and lots of this logic that could help you a lot right away. So let's start with commands verification. Eventually, when you're firing any Selenium command, you're expecting an exception or an error message if the command wasn't executed successfully. But as you maybe already know, that is not always the case with Selenium. Lots of times you're executing your commands and you're not getting any exception, any error, but eventually the command wasn't executed successfully. If, for example, you're clicking a specific button, the click doesn't throw any exception or doesn't return any error, but eventually the button wasn't clicked. And this happens, more in IE or something like that, but it also happens in Chrome and Firefox. So what we recommend to do is, you're depending so much on your machine, on the automation, but here we say check or verify that the work has been done correctly. For example, here we have 3 examples. There are tens and hundreds of other examples that we can outline. So let's say that you're using send keys. You're sending a specific string to the input field. So after post command execution, verify that eventually the string that the input field is holding is eventually the desired result. That's what you want to do. That's what you wanted the send keys to do. So sometimes there would be maybe leftovers from previous steps, and the send keys would just concatenate the string that you have sent in this instance of this command, and just could be that send keys eventually wasn't successful and you didn't get any exception regarding that. Regarding the click, the second example is about the click. So let's say you're clicking a button. Usually when you're clicking a button, there's some listener on that button, whether it's on click, ng-click, depends on the framework that you're using. Eventually those functions or methods should be fired once you click the button. So you can verify that they have been fired in your browser post clicking. If for some reason they were not fired, you can retry your click in a, let's call it a smarter way. For example, clicking using coordinates in the middle of the button. That's, one idea. Third example, move the element. I'm sure that you use that a lot in your tests. Can just verify that the element is in focus post execution. You can do that using a JavaScript command. There are lots of ways to verify that, but with just one line of code or 2 lines of code, you can save yourself lots of flakiness, because the following steps are dependent on the move element, the click, the synth keys, no matter what, has been successful. And if they were not, so your test is likely going to be failed. So that's regard commands verification. As I mentioned 2-3 minutes ago, those are only 3 examples. There are hundreds of such examples, and there are already tools in the market that have implemented lots and lots of stuff like these to lower your flaky tests. And we're going to mention one of them in a few minutes, that you can just plug and play with your existing Selenium tests and just enjoy all those algorithms. The next pitfall is not maybe more a best practice than a pitfall, is using dynamic element locator, and that would be our last best practice for today. So locators eventually will be changed. Eventually they would break your tests. Okay, you can lower that to a smaller percentage, but still, the pages would be updated, and locators would be broken. So what we recommend to do is, the first step, you can use multiple locators. So if you're locating an element using an ID or a class name, or if you're locating it using an ID, maybe you can add also a class name. If the ID fails, then you would go to the next one, try locate it with the other locator that you have set there. But that maybe would help a little bit. If you're looking for a well established solution for this issue, you can use tools that generate valid locators during runtime. And this is one example that we can outline here. Well, and with the example, I can explain that a bit better. Eventually, what those tools offer is that anytime, let's say, a find element is, you got unable to locate an element here after the find element, then that means that, or at least here in this case, this means that the locator was broken. We're unable to find the element using the specific locator here. For example, it was a CSS selector name equals Q. So this locator has been broken. So we're using Radview test automation. That's our own product, which you can use, and it's just plug and play with your Selenium tests. And so what the product has done here is we're listening for such exceptions, and once we got unable to locate an element, then our algorithm for dynamic element locator kicked in, an AI-based one, and eventually the algorithm came up with this locator, and this locator eventually was successful, and we were able to locate the element. and let the test continue running successfully. So as well, trying to go for dynamic element locator, as we've mentioned, with commands verification, it's something that we recommend to do using an external product or tool, because eventually implementing those best practices or those functionalities takes a lot of time. It takes eventually, complete R&D teams working, months and years to build such solutions. Also, for example, here we've mentioned that using AI. So that's not a thing that I would do in-house. If I were you, ROI wise, it doesn't make sense. And so that was our last best practice that we wanted to cover here. And let's do a quick recap of all the best practices that we have covered. So use explicit weights and not implicit weights. Aim for what we call automation locators. Make sure that the properties are being added to your elements with a unique prefix that everybody knows that those are test automation locators. Get your strings from your strings management system and not have them hard-coded in your testing framework or in your tests. Rerun your failed tests. Keep utilizing your machine resources for the best results. You don't want to run your tests on a burned machine like we saw in the specific slide. And the last two, we recommend using specific tools for commands verification and dynamic element locator. So make sure that you verify that the commands were executed successfully post-execution. And when any locator was broken, make sure that you have a mechanism that can come up with new valid locators during runtime. When your test is running, if a locator was is suddenly failing during runtime, the algorithm can get you a new valid locator and let the test continue running successfully. So those are all the best practices that we have covered today. We want to let you know that our product, Radview Test Automation, is an AI-based test automation platform which eventually implements all the best practices that we have covered today, the ones that we can implement, and lots of other best practices that eventually help you to get to less than 1% flaky tests, and using dynamic element locator that we have mentioned, using lots of AI mechanism there. And we've mentioned at the beginning that once you have any failed tests, then all the automatic stuff, all the automation stops there, and all the manual stuff kicks in. You try to investigate and find the root cause of the failure manually. So Radview Test Automation does that automatically also for you. We can pinpoint the root cause failure right away, also using AI. And lastly, since we're talking a lot about Selenium here, Radview Test Automation is the only product in the market which can integrate automatically with your Selenium-based tests. So just plug and play with your existing or maybe future tests. If you're planning to start a new project, you would continue working with Selenium as you are used to today, but you would enjoy all the best practices, the algorithms that we have mentioned behind the scenes on top of your existing tests. So that's it from our side. Now moving it to David for the Q&A session.
Thanks so much, Firas, for such an insightful session. We've got already a couple of questions here from the audience. I'll start with the first one. If I run my tests in parallel, doesn't it take more resources, or should I avoid that in a way?
Sorry, can you please repeat the question?
If I run my tests in parallel,
Mhm.
doesn't it take too much resources? Should I avoid that?
You definitely shouldn't avoid that. It does take more resources, but you need to make sure that the machine is powerful enough um, to run 2, 3, 4, maybe 10. I wouldn't go for 10, but 2, 3, 4, maybe 5 threads, 5 browsers in parallel. So it depends on the application that you're testing. If you're testing an application which is very heavy and it consumes lots and lots of machine resources, then I wouldn't test. I wouldn't run more than one browser on a machine, but I would run the tests in parallel on different machines. So you can do that on your own. You can manage your own, let's call it lab for your testing, or you can use, there are lots and lots of external tools which eventually provide lab for your test automation. So as much as you want browsers and machines to run your tests in parallel.
Thank you. I'll go to the next question. Should I use the same machine like the user would use when testing?
So here that's a tricky question. Why? Depends on your goal in your testing. What we recommend that you should have unique tests or specific tests for every different purpose in your testing. So let's say you have tests which are testing the functionality of your application. So if you only care about the application, you don't care, let's say, for example, about the performance of your application in those tests, then go for a very strong machine and without any relation to what types of machines your users are using, because eventually you're testing only functionality and you don't care about performance. And so we recommend to go with functional tests with a strong machine, but we recommend you to go for performance testing as well, and that would be having machines which are closer to what your users are using, and then you would be able to understand what is the experience that they're having using such maybe less powerful machine, and find the issues there. Functional tests and let's say performance tests are different tests, so we recommend to separate those and hope this answers your question.
Right. I think we covered it all. If anyone else has any other questions, we are here to address them. If not, I'm just reminding everyone that this session recording will be sent within the next couple of days. You may follow our LinkedIn page, just shared within the chat here in Zoom, to stay updated with our upcoming events and content. We very much hope you enjoyed the session and find it insightful like we think it is. And see you soon in our next webinar. Cheers.
Thank you, guys. Have a nice rest of the day. Bye-bye.